Welcome each one of you to my YouTube channel Truly AI. Through this channel, we try to explore artificial intelligence in a simple, straightforward, real and relatable way. I am Dr. C.B. Abraham, a professor with around 30 plus years of experience in the field of artificial intelligence. If you recall, in the previous episode, we discussed what is artificial intelligence through a simple kitchen story. Today, we expand that story. How do machines actually learn? No theory, no jargon, simple talk straightforward. Let us move to our lab, the kitchen. Have you noticed my expression? Yes, you guessed it right. I am confused because I am the new chef over here. It is my first attempt. I have been provided with some ingredients. In machine learning, all these ingredients are called features. I am told I could be able to learn cooking using these ingredients in 3 ways. The first, I have been provided with a mentor chef. He will be able to assist me, help me, guide me in order to make, say, a sandwich out of these ingredients. Second, no mentor chef, no guidance, no supervisor. I have only been provided with these ingredients, but I can taste, I can make combo of these ingredients to see which of the ingredients actually work, and gradually I could be able to figure out which ingredients could help me to make a good sandwich. The third, no mentor, no trial and error method for tasting, but I can make and give to you, the guest. I can look at your face expression and correspondingly I can judge whether you liked it or not. If you have a smiling face, yes, I will get the idea that you liked it. And suppose your face is not showing any happiness out of having that sandwich, I feel that something was wrong with the preparation. I can do this a number of times and correspondingly I will be able to learn what provides, what gives a good sandwich is. Therefore, correspondingly, we have 3 different approaches to make a sandwich out of these ingredients. First, a mentor chef who will be able to assist me, and correspondingly in machine learning there is a type called supervised learning. Corresponding to mentor chef, there is a supervised learning. The second, corresponding to trial and error method of checking which ingredients go together in order to make a tasty sandwich. Correspondingly, we will have a machine learning technique called unsupervised learning. Thirdly, serving a sandwich and looking at the feedback, the comments, your responses, and in the process learning how to make a sandwich. And correspondingly, we have the third type of machine learning called reinforcement learning. Here I am, the new chef with a mentor chef. Along with the features, here we have what is called a label, which is nothing but the sandwich, which is given by the supervisor or the mentor chef. Any data set which involves the ingredients and the label is said to be a label set. Then let us focused on what is called supervised learning. I try with one bread and I know what I should do. I have to get something like this, and correspondingly I make this and give to the supervisor, my mentor chef, and of course he compares that this is my product and this is the product I am expected to provide, and there is a big difference between them. The supervisor wants my creation to be exactly equal to that, and that difference is said to be the loss. The loss is nothing but the mistakes score. Suppose this product carries 10 out of 10 and this my supervisor gives a value of 5. 10 minus 5 will be the loss value. As a good chef, my objective is to reduce this loss as minimum as possible so that my creation would be exactly equal to this. Based on the first attempt, I gave it to the label, compared it, and there is a loss value. In the next attempt, my objective is to reduce that. I provide this way, my creation is this way, and I give it. Corresponding comparison is done. The label value 10, this one, maybe the supervisor, the chef could be able to provide a value of say 7 out of 10. What we wanted is 10, what I got is 7, therefore 10 minus 7, that is the loss value 3. I could be able to reduce the loss from 5 to 3 now. I have learned that yes, my process is good, I need to improve upon. We make lot of changes in that, and now I give it to the mentor, and the mentor compares this and he gives a value of 9 suppose. Therefore the loss value could be able to be reduced. Therefore I have learned in the process to reduce the loss from 5 to 3 to 1, and yes, I could be able to experiment on further thing, and correspondingly I could be able to look something almost equal to this, and my supervisor, my mentor is very happy, and he could be able to give a rank of 10 or a score of 10, and the loss value is 10 minus 10, that is equal to 0. That means I could be able to meet the expectations with respect to this data set. And this is what exactly machine learning does in the case of supervised learning. Corresponding to the features and in comparison with the label, machine could be able to learn iteratively, and one stage will come, the expectations is matching with the actual product delivered, and this process is said to be what is called the training in the supervised machine learning process. There are different instances where the supervised learning play an important role in our day-to-day life. When you look at your Gmail account, you could see the emails are classified into different types: primary, some forums, updates, spam, etc. These are nothing but the different labels, and the Gmail could be able to understand as soon as an mail comes, it belongs to which, and corresponding it could be able to label it. Therefore, this is a typical instance of supervised learning. I am the same new chef. In this case, we have only been provided with features. There is no labels. That means no sandwich is given as the output we want to create. Only the ingredients and we have to figure out ourselves what is to be made out of this. Suppose I take only bread and try to taste it, no taste. Suppose I add some vegetables and try to taste it, maybe slightly improved, but it doesn't look so nice. Then I add some more vegetables and try to add a little bit of chutney to it. I tasted it. Taste is better, but it doesn't look like something could be able to be given to somebody to eat it. Then to the next level, I try to pack it and I try to eat it. Yes, it looks good. And this is what in the unsupervised learning process. We have an unlabeled data. We have only the ingredients, bread, cucumber, say tomato, etc. And these are only the ingredients, that is only the features, no labels in all over there. There are many examples where we deal with this type of unsupervised learning. When you order something on the Amazon, after purchase, you must have seen a message, people who brought these items also brought this. This is a typical example of unsupervised learning. And also when we watch Netflix movie, there are some recommendations coming to you saying that based on your taste and your interest, these are the possible movies you could be able to watch. I am the same new chef, but there is a difference. There is no mentor chef to guide or support me. And also I am not supposed to make by myself and taste and learn in the process. Based on these ingredients, suppose I make it and give it to you. You taste it. Yes, I could see you the face, you did not like it. Therefore I learned that this is not the way to make a sandwich. Therefore I slightly change it and add some more ingredients and give it to you. Your face shows that it is slightly better than the previous one, but still this is not what you wanted it. In the process, we continue to do many experiments, and each time we try to add something and see the feedback, response, comments from you, and that comments, feedback or responses will help me to understand whether you liked it or not. If it is a positive response, I will continue to move in that direction, and if it is an adverse comment or negative reinforcement, I get the understanding that this is not what you are looking at it. In this process, at the end, I would be able to give you what exactly you are looking for, and seeing your face, I understand you liked it, and that is what the reinforcement learning. Reinforcement learning is a machine learning type in which the machine randomly tries different variations and look for the feedback and continuously working on that feedback and improve the strategies, and at the end the machine could be able to provide the best what you are looking for, and that is reinforcement learning. There are different instances of reinforcement learning in our day-to-day life. For example, you watch this YouTube video, and if you like this, you may give a good positive comment, and that comment will help me to make better videos in the same direction. And if suppose if you are providing some feedback which is not very positive, I feel that this strategy is not working, I need to incorporate some other suggestions or I need to recalibrate my strategy, and correspondingly it could help me to make a better thing. Therefore, please provide comments so that I could be able to improve my videos to reach to a larger audience who are looking for artificial intelligence related topic in a very non-technical, real and relatable fashion. We learned 3 different types of machine learning: supervised learning, unsupervised learning and reinforcement learning. In all these 3 different types, the chef was learning the process. In machine learning, it is called the training phase. The chef has not experienced the real world. He has not actually given the sandwich to an actual customer, and after learning, after training with many such instances, suppose the chef is confident enough to be deployed in an actual real life scenario. Suppose the chef has been employed in a hotel and it is the first day in his job and he faces the customer, and now the customer comes and he asks for the requirement of the customer, and suppose the customer wants a grilled sandwich. Remember, he has learned the ways of learning or the different ways of creating different types of sandwiches based on the ingredients provided. Maybe at that instant, some of the ingredients may not be available, or the chef may not have been trained on creating a specific type of sandwich, that is the grilled sandwich. All the training process undergone earlier only helped the chef to make the real life better, but that is not guaranteeing. Similarly, a machine learning which only focuses only on the training data but without understanding the structure, the concepts and the process of the learning could not be able to deliver to the demands of the real world. We do not want the machine learning to just train on the data and focus only on the training data, but we want to have the machine to generalize the understanding to face the real cases. Therefore, we will be having another type of data, what is called test data. Therefore, test data evaluates the efficiency of the model created. A model which could be able to provide good result in the case of test scenario then could be able to face the real life situations quite comfortably, just like a chef who could be able to satisfy the requirement or demands of a customer on a daily basis, and that is what the expectation of a chef is, and similar is the expectation of a good machine learning algorithm is. Not just learn based on the training data, but understand the concepts, generalize that understanding and could be able to give the real life solutions whenever it is expected. Remember the supervised learning? The new chef with the master chef, the ingredients, the features along with the label, that is nothing but the sandwich. The label can be of 2 types. That means the supervised learning can be broadly divided into 2 types. First, the sandwich, the label can be called a categorical label, in the sense that the sandwich can be different types of sandwiches: veg sandwich, grill sandwich, Then some other different types of sandwiches. That means the label is nothing but a categorical value. Such type of supervised learning is said to be classification. The second type of supervised learning is regression, where corresponding to the different features, the label is not a categorical value, but it is a numeric value. Suppose based on the taste of the sandwich, different values can be say 8, 9, 10, 6, etc. That is nothing but the score or the value for that particular sandwich. And that label value, which is represented as a numeric, is said to be regression. Therefore, supervised learning consists of two types: classification, where the label is a category, and regression, where the label is a numeric value. Here we have in the machine learning playground, the playground where we could be able to play with different data and different machine learning algorithms. Assume that we have two types of data. One is images of dogs and the other is images of cats. Obviously, the images will have a lot of pixels. In order to make it simple, assume that there are only 2 pixels. We try to represent cats and dogs in just 2 pixels, just 2 dimensions. Here we try to plot some data corresponding to, suppose this is cats. These are some of the data points corresponding to cats, and other corresponding to, suppose, dogs. What is our objective? Our objective is to properly separate this orange one with the other one, cats, from the dogs. Remember, we have 2 different colors for this. The labels are colors. Therefore, it is a labeled data, and this is a typical supervised learning with what is called the classification. Therefore, we want to classify these data points so that when a new image comes, a new data type comes, we should be able to properly segregate that belong to which color or which image, whether cat or dog is. Here we have different machine learning algorithms are provided. We will discuss each one of them in subsequent videos. Suppose we focus on the k nearest neighbor. We train it and see that we will be able to have the separating surface. Therefore, all the data points in this area is referred to this orange, and all other data points in the other side belong to the other data type. Then here hardly any 1 or 2 misclassifications are there. Therefore, the model is not perfect but somewhat good in classifying the images. Let us move to another model called perceptron. Then we train this, and you could see that it is very miserably failed in separating the separation surface such a way that all the data points on one side and no data points on the other side. Therefore, this machine learning algorithm miserably fails in separating the 2 types of data points. Let us move to the third one, support vector machine. And here, yes, it is better than the previous one, but the model is not that good because lots of misclassifications. All the orange data points comes this side along with the other one. Therefore, the model is 60-70% good but not that great. Suppose we focus on this decision tree, the other data type, and here we could be able to have this type of separation. but better and could be able to separate or classify data point somewhat nicely. Then we can increase the size of this. Suppose we make this 10 to 50 and train it, and still we will be able to get the same response. That means the model has reached to a level wherein which no further improvement is possible. We have played with the different machine learning algorithms, of course without getting into the technicalities of it, like k-nearest neighbors, perceptron, support vector machines and decision tree. And we have seen how each method treats the data set in the process of classifying the data points. Some of the models could not be able to perform better. Some of the models exceptionally performed good in terms of segregating, separating, classifying data points. Therefore, depending upon the type of the problem, we could be able to use a type of machine learning algorithm. This is a sandwich we made together. In the process of making this sandwich, we have learned how machine actually works. No theory, no jargon, in simple terms. Before tasting this sandwich, I would like to know, how did you like the video? If you like it, please like, share and subscribe. Please wait for the next video. Thank you for watching. Till then, truly AI.